So let's begin with the second question of this particular paper. We are given that a particle P is projected vertically upwards from horizontal ground with speed 15 meter per second. And we have to find the speed of that particle when it is 10 meters above the ground. So let us draw the situation over here. This is the ground. Let's assume that. And our particle is, let's say, somewhat like a small object over here, a particle which is having initial speed of 15 meter per second. And we have to find out the value of the speed of this particle when it reaches the 10 meters above the ground. So let's say 10 meters somewhere over here, okay, above the ground. Let's say this distance is 10 meters. So what's the value of the speed when the particle is coming over here? That's the question. All right, so now what we can do is we are having the value of s. I'll just mention it down over here. We know that the value of s is equals to 10 meters. We know that the initial speed is given to us as 15 meter per second. We know that or anytime we are moving in the y direction, the acceleration is always minus 9.81 or minus 10 because we are dealing with AS level mechanics of Cambridge, and Cambridge suggests that the value of gravity should be 10, right? So minus 10 will be the value. If there is no force existing on this particle, which is the case over here, there is no force, and in y direction it would be 10 or minus 10 I should say. And yeah, we have to find out the value of the final velocity when it reaches the 10 meter spot. So we are having SUAV. So if you think about it, we can use the formula v square equal to u square plus 2as to solve this question. So we can say that v square equal to u square plus 2as, and therefore the value of v will be equal to square root u square, 15 square plus 2 times minus 10 into 10. This minus 10 is for the acceleration due to gravity, and this 10 is the amount of distance that it's going to travel. And therefore, if we find out the value of v from our CAIE, let's see what do we get. So here is my CAIE, and we are given the value of square root of 15 square plus 2 times minus 10 into 10. And the value comes out to be 5 meter per second. So as expected, as it goes upwards, the speed decreases, right? So 5 meter per second will be the value when it is 10 meters above the ground. So that's the answer of the first part. Now, as we go ahead, let's see what do we have for the second part. At the same instant that P is projected, a second particle Q is dropped from a height of 18 meters above the ground, and it's in the same vertical line as P. And now we are asked to find the height above the ground at which two particles collide. So let me just redraw this diagram over here for the second part. I don't believe any kind of first part answer will be required over here. But anyway, let's try to draw what is the situation. So here is the ground. Here is particle P, which is thrown upwards, vertically upwards at 15 meter per second. At the same time, particle Q is also dropped from a height of 18 meters above the ground. So this distance over here basically is 18. This total distance is 18 meters. Or else I can also write in between, but anyway, this height is 18 meters. This is particle Q. And let's say that it collides somewhere over here. Let's say that this is the point of collision. All right, that when Q comes over here, and when P comes over here, they're going to collide. So what's the distance that P has traveled? Let's call it SP. And then what's the distance that Q has traveled? Let's call it SQ. Now from this SQ and SP, if we add them together, the total should come out to be 18, right? Because that's the total height. Because it's going to intersect in between, or they're going to collide in between. We know that this height that P has traveled before the collision and Q height that Q has traveled before the collision, the summation of that, the total of that will be this plus this, which is, as you can see over here, 18. So from this, we can make this equation that SQ plus SP is equal to 18. And therefore, if I want to make SQ the subject, you can also make SP the subject, it's up to you. But yeah, if I'm making SQ the subject, it's going to become 18 minus SP. Now we have to find the height above the ground at which two particles collide. So basically we have to find the SP height. That's the main question. What's the height of SP? And let's see how we can do it. So first of all, let's try to get the equations of SP and SQ if it's required. All right. So SP is equal to, we are going to use S equal to UT plus half AT square. S equal to UT plus half AT square. That's the equation that we are going to use. So what is the initial speed of particle P? It's given to us as 15. So that's 15. Then T, because we don't know the value of time at which it will collide, we are just going to write it T. Then plus half, the value of A is minus 5. And then the value of T square. Now, if you notice, we don't know the value of S, we don't know the value of T. So we'll require one more equation, that is, we will get with respect to SQ. Obviously, if you want, you can create any other equation as well, in which you get S. Basically, there should be two unknowns. Over here, I know that this SQ has been converted to SP. So I can surely create one more equation with two unknowns, that will be SP and T. And that's the reason I'll be using the distance of SQ, right? And it also makes sense to use that, just like we have done it for SP. Why not if we can do it for SQ? So therefore, if I also have to make the equation of SQ, which is nothing but 18 minus SP, then I'll be getting my SQ. Now remember that this distance is traveling in the opposite direction. So it will be minus of SQ. So minus SQ, where SQ is 18 minus SP, is equal to, because it was dropped. So whenever we say it was dropped, it means the initial speed was 0. So it will be 0t plus half a t square. Remember that whenever we are considering the y motion, I'll always choose the acceleration because of gravity as minus 10. All right, I've written minus 5 and minus 5 over here. That's my mistake. I should have written minus 10, right? Not minus 5. It should be minus 10. Over here also, it would be minus 10. And then minus 10 times half will become minus 5. But yeah, that's the thing that we will have. So now we are having two equations. This is the first equation and this is the second equation. And now we can just take this equation and solve it simultaneously. So this will be, if I open, instead of SP, I can fit all of this, right? When I'll be opening this bracket with a negative sign, it will be SP minus 18. So SP is this 15t minus 5t square. That's my SP. And then there is minus 18 is equals to minus 5t square. And if I solve for t over here, I can clearly see that this term and this term is getting cancelled out. Therefore, the value of time will be equal to 18 over 15 seconds. So now I know that if I substitute the value of time over here, you will get the value of SP, the height above the ground at which both the particles collide. That's what we wanted. So what I'll do is, I'll say that, therefore, SP is equal to 15 times 18 by 15, which is just 18 if you simplify. Then minus 5, half into minus 10 is minus 5. And then 18 by 15 square. And now if I solve this in CAIE, let's see what do we get. So it's basically 18 minus 5 times 18 by 15 whole square. So it's coming out to be 10.8 meters. So that will be the answer of part B of question 2. Let's see if we are having question C. All right, no, we are having question 3 directly now.